Welcome back to the People of Construction and Development podcast. This week, we're going back underground as I chat to Tim Mitchell, a geo-environmental consultant and director at Omnia Consulting. Tim tells me how he uses his expertise in order to clean up contaminated land in the most efficient way possible.
It saved our client tens of thousands of pounds.
Why you shouldn't judge a book by its cover when you're looking at a potential development site.
And generally, ground gases can migrate around about 250 metres, depending on geology, to your site.
What could happen if contamination is not dealt with thoroughly?
And that is what led to the drastic step of having to demolish the buildings.
And he shares some advice for graduates at the start of their career.
I'd recommend doing as much work as you can do outside of your course, even if it's a summer just shadowing a consultancy firm.
So I hope you enjoy hearing about this often unseen but very important part of the development process. I kind of sort of know what you do because I worked with you on a few projects and talked to you several times at networking events and that kind of thing. But when you get asked by people what you do, how do you explain to them what you do?
Right. Okay. It's not really that easy an answer. So I'm a geo-environmental consultant. So what that is looking at brownfield sites, assessing them for any risk associated with the past use of the site, and then if needed, we do investigation to see if they do pose a risk. If they do, we work out what's needed to mitigate that risk, make it suitable for the intended use. So that's one part, but also because we're looking at the ground for the contamination, we also look for foundations. We work out soil properties, look at the strength of the ground, and feed that into a foundation plan. So that's it really in a nutshell.
So your sort of involvement in the stages of a development, would it be primarily up at the early stages up front, or are you involved all the way through to the end of construction, say?
Okay, so mostly we'll get involved. At planning stage. Often planning conditions come through that say no development can commence until XYZ. One of those is the site has been assessed for risk to human health and to the environment. So we'll prepare a report at that stage that will allow discharge of the condition, or maybe extend through to the next round of assessment. So that's the first bit. We are then involved all the way through the project. If the site is contaminated, we'll work with a developer to get a development platform in place, and then right at the end, maybe we'll be checking, we'll be validating to ensure that remedial measures have been put in place. Often this can be just before sign off, CML they call it, sign off to allow release of mortgage funds to the residents. So it is all the way through, really.
Okay, so I guess you're advising initially on potential risks and what costs could be involved, all the way through to the end point of saying what was needed to be done has been done, and people can now move in, say, to their houses. That's it.
And there's that aspect, but we always also do, as say, environmental consultant, and we'll do due diligence assessments as well. So it can even be a change of ownership, purchase of an industrial park by a pension fund, and I would usually go to site and do an audit, do a survey of the whole area, and work out the risks associated with that, so it can feed into land deals as well.
So how did you get involved in what you do now? Did you study a a certain degree at university?
Yeah, that's right. So I studied for applied geology, did a bachelor's degree in that. As part of my degree of geology, we did an amount of, well, site investigation module, and I actually wrote my dissertation on site investigation techniques and foundation assessments. So that was great. That was great for me to get into the industry. I was able to find a job relatively quickly because there was transferable skills from the degree to what you actually do in the workplace.
Did you do some work experience during your course to sort of get a feel for what the job involves?
Yes. So my dissertation, if you like, that was the final year of my course, and that involved working with a company in industry. They gave me a project, a site to look at, and I worked with their site engineers, their consultants, running the project all the way through as much as possible. But crucially, I guess, going to site, spent a week on site with them, and then did return gas visits. They then went ahead and wrote a report. I was not provided any of that data, or I couldn't see their report, but I had all their logs, all their chemical results, and I took that and I was able to produce a full report as well for the dissertation.
Yes. So it's quite a applied sort of dissertation in a way. It was kind of real life. You're looking at an actual site and development, I guess, as opposed to something really theoretical.
Yeah. What I'd add really is, for any graduates, any people at university at this time, I'd recommend doing as much work as you can do outside of your course, even if it's a summer just shadowing a consultancy firm, because even if you just get 2 weeks in there or a month of experience, that's going to set you apart from the rest of the graduates that are applying as well. So just get on and do that. Make that effort, and it should go a long way.
Similar to how I might have started my planning career, I guess, is that I didn't necessarily know what I wanted to do. I was doing geography, and we did a module on planning, and maybe in the second year, and that's how I kind of got to know more about it. And then from there was a work experience placement for 2 weeks, I think, or a month over a summer holiday, and I chose that. I worked in a local authority and just went from there, really. But I think, as you say, that building that work experience, one, it lets you really understand what the job is about, and two, yes, as you say, it's something you can add on your CV, and you have that little bit extra than someone else might not have. I think you're going to tell me a bit about a project you've been involved in the southeast that involved, was it diesel pollution on an industrial site?
Yeah, that's right. So I mean, this project's one that I'm pretty proud of what we've done as a team here at Omnia. We looked at a brownfield site that had previously been assessed by others, and the intended scheme of remediation was to dig out a diesel plume under the ground. So the plume had come from some fuel tanks that had been there for 30 years, and they'd leaked. But rather than dig it all out and take the soils to a landfill site, which is kind of it's a traditional approach, and it's something that was done, as contaminated land has developed, that was a kind of earlier approach. But since then, we've come to be more focused on sustainability, and as much as possible, you want to keep out of that landfill, because all you're doing is transferring the impact to another place, making the trouble for later on in the day. So on this site, we were able to do a combination of things. We did some detailed groundwater modelling. We looked at the actual concentrations of the water, and then we did a risk assessment to see really, I guess, what the risk is of the contaminated water traveling to a certain point, control point they call it.
Is that the modelling process? Sorry, so you model, here's where the oil is seeping into the ground, say from the tank, and here is it. Do you look at how the groundwater flows across the site, and it sort of says it's likely to have moved across to this position?
That's spot on. That is. So it's called the DQRA, and that assesses all of those things. So you look at geology type, you look at the groundwater level and how that might fluctuate. You look at the permeability of the geology as well, to see how that kind of hinders the movement of the contamination in the water. And then you have a set point where contamination can't reach. So for this one, the set point, the compliance point, if you like, was a groundwater abstraction for a local water supply. So we had a set criteria. The modelling that we did was able to show that a certain amount of the plume, if you like, could be left in place, whereas other areas of it were a little bit too high. So that area was excavated, and then there was ex situ remediation, it's called, where you take the soil out of the ground, keep it on site in this case, you release microbes into it and keep turning the pile over. It's a biopile, they call it. Over time, the concentrations in that pile will reduce because of the microbes and their digestion of the contaminants. And once it reaches that level, because you do periodic testing, once it reaches the lower level, that can be then put back in the ground where it originally was.
What sort of timescales are involved in that process for the microbes to do their business?
Yeah, I think it's going back a little bit, but I think it was about 2 months to get it to work. And there was a need every week. We went through the pile and turned the soil over, just aerated it, to kind of give a bit more energy, if you like, to the microbes.
And then you put it back in, and then essentially that site's then safe for the end user.
That's right. Yeah. So on that site, we had to put some membrane, it's called, in the houses, so that no vapors could come up from the plume. And then we also had to do validation, we call it, at the end, where we take water samples from points around the edge of the site, through the housing estate, and test it to show that the water now conforms to a set of values that our original modelling has said. So yeah, it was great because it saved our client tens of thousands of pounds through doing that. The issue you might have, though, is it takes some time. If you need it done straight away, that's why they look at doing a dig and dump kind of thing. But there's still off-site treatments you can do as well.
Yeah, I guess one of those things, if you know about it earlier on from your initial risk assessments and surveys, that you can factor in, can't you, to get rid of it in the most efficient way, and in that case, enabled cost savings. What's the worst type of contamination that you can come across on the site? What's the most difficult one to deal with?
Well, I mean, in the everyday, I'd say asbestos is a really difficult one to deal with. Handling asbestos. Once you know asbestos is there, you have to get in certified people to look at that risk, to even sample it in some cases. You need compliance testing around the edge of the site to make sure there's no asbestos going off. So that can be a problem. I think the issues it's usually on the sites where you have a combination of factors that it's the most difficult to deal with. So, for example, we had a site just by the Thames, and it was tidally influenced. So, once or twice a day, you could have access to the impacted soil to excavate it. But then, when there was a high tide, you had the water level rising up, and you couldn't do any excavations. So, it's kind of the practicalities around it that make it difficult.
Yeah, I guess every single site's unique and has its own challenges, and be that certain constraints. There might be, I guess, trees or structures or soil types, and I guess that gives you quite a bit of variety in your day to day.
It does, and it makes you think as well. It kind of challenges you to work out a way that it can be done with both, the environmental perspectives and the client's expectations as well.
Another thing you sent to me was the ground gases, and was that in relation to a development site, housing development in Scotland? Is that correct?
Yeah, that's right. So a couple of years back, there was a housing estate in Scotland, as you said, sorry, and residents were complaining about headaches and all sorts of things that, they were going to the doctors and complaining to them, and it kind of was tracked back to showing that there was a migration of gas into the properties, so ground gases. This is methane, carbon dioxide, carbon monoxide, that kind of thing.
Is that caused by historic use, or can it be completely natural?
So it can be natural. Yep. There's areas in Portsmouth where we've got a lot of peat, where we've got a lot of organic material, which was deposited there as the sea moved, as channels were infilled, that kind of thing. But more often than not, we find that it's associated with man's influences. So a landfill site where they're putting domestic waste into the ground, a historic landfill site where there's been some uncontrolled deposition of the waste. The landfill might not have been sealed properly. And generally, ground gases can migrate around about 250 meters, depending on geology, to your site. So that's why something we always do in the first stage in a desktop study is look for sources within 250 meters to the site, look for landfill sites, and then that often leads to a requirement for gas monitoring.
Essentially, you have a site which you think has never been used for anything other than a grazing field, say, but 250 meters down the road there was a landfill site, and that your site is actually quite contaminated, but without that sort of initial due diligence, and you wouldn't actually know. Yeah. So on this site in Scotland, then the gases were coming into the properties.
That's right. Yeah, they were coming into the properties, and there was a lot of assessment done for the site by all sorts of technical experts, and at the end of the day, the local authority decided the best option was to demolish all of these houses. Now, this was very upsetting, of course, for all the residents that were living there. These were new houses as well that had just been built, so they had to move out, be compensated, have new homes. But what it kind of identified that there was not much guidance there on how to retrofit gas protection measures. So usually when you build a house, if you know there's a ground gas risk, you can incorporate measures. The risk can be mitigated. There's kind of set protocols of what you do, how you calculate what's needed. Once you build the house, what do you do then? Because it's actually the building fabric that needs to have the measures. Often you'd have a membrane across the floor slab going over the cavities of the wall. But if the building's already up, how do you get access to those cavities? That kind of thing. So out of that, industry experts got together and produced some guidance, which had just been issued, in fact, as to what you might do. And this includes membranes within internal walls, how you can mitigate risks across the cavity, some liquid membranes, those kind of things. So it's cutting edge, and we've in the past we've seen that as a problem where we've had change of use of developments. So it's now that often the case locally to here in Portsmouth, and I guess elsewhere across the country, and we've got a lot of student accommodation where office buildings are being converted into residential. So that's all well and good, but what happens if you work out there's a gas risk on your site?
Is that because the risk to people living in the building is more than the risk of someone working in the building? Does risk factor in that sort of amount of time people spend or what they do inside the building, and is that why it changes?
Yeah, you're spot on there. What it is if someone's living in there for 24 hours a day, they could possibly be there. They keep the windows closed in the winter. You can have gas build up. Now, if you compare that to an office use where people might be in there for 8 or 10 hours a day, there's people coming in and out of the building quite a lot. Often you'll have ventilation, you'll have your windows open. It's a different level of risk. So yeah, that's why it needs to be considered.
Case study in Scotland there. Who is responsible for putting those measures in? So is it the owner of the property, or is it the person or the developer that built the properties?
Well, often with new builds, they'll have a warranty provided by the NHBC, say. So usually that would fall under NHBC warranty, that mitigation measures could be put in place. Because the NHBC themselves, they do require and they do apply all kinds of it's almost like planning conditions. They call it land quality conditions, where certain things have to be met. There has to be a death study, there has to be a risk assessment. So the NHBC themselves have to be happy with the risk assessment that has taken place for them to supply a warranty to the property. So I'm not saying that was the case on this development, but that's often the case on others.
Okay, and then I guess that's why it's important to have the risk assessment, a thorough risk assessment, and the remediation sort of early on, so that can all be factored into not just the development but the purchase and the insurances and warranties that sit behind it as well.
Seems for whatever reason the risk wasn't assessed at the time of the construction of the housing, and that is what led to the drastic step of having to demolish the buildings.
Yeah, you can imagine there weren't very many happy people there. So I'm quite keen to hear about the sort of latest things that are happening in different sectors and that sort of thing, and what people see as being important over the next sort of year and beyond. What do you think is going to be important in your field going forward?
Well, I think the driver is a lot for sustainability. Really a big thing is management of materials on site, retaining soils on site rather than taking them to landfill sites. So for me, it's that agenda is ever increasing, tracking the soils. The framework that's in place for reuse of materials on site, it's industry led, and this has been a trend for some time, that rather than when I first got into the field, there was a lot of guidance from the Environment Agency. They issued soil guidance values. They actually used to review all of our reports. And since then, times have changed, funding has changed, and it falls to the local authority to review a report, and for the EA, the Environment Agency, to be consulted if the local authority are unsure or if it's a controlled waters issue. So for me, the where we're going, I think, is a lot more industry regulation and striving to improve the quality of the reports, the technical reports that are written.
Move towards more on-site treatments. Is that something that gets better as time progresses? Are there new techniques and new methods to do it, or is it the case that there's tried and tested things that work and that is the best way to do it?
No, it's evolving all of the time. There's a lot of new products, chemical products that are coming onto the market. We look at in situ remediation. you can add product to the ground that reacts with the hydrocarbons and breaks it down, so you don't actually have to excavate. I spoke earlier about biopiles, where you treat the soil once it's mounded on the surface, but often you can do chemical injection into the ground, and then you measure how the breakdown of the chemicals are going on over time. So it is a lot of new products are coming to market at the moment.
Yeah. So the future's potentially quicker cleanup in a more sustainable way, I guess.
Yeah, that's right. That's right. And a good thing that can be done with in situ remediation is, as long as you can demonstrate to the local authority that the risks are being mitigated and construction won't make the risks greater, you can often allow building to carry on the site. Houses can be constructed, you can be injecting remedial chemicals into the ground around them as well. So again, it's all site specific and geology and regulator agreement and so on. But the thing is developing land, because it always costs the developer to, if you're sitting there with an empty field while the remediation works are happening. But if you can close that down and just push on with the development, reduce the financial burden, and so they can get the payback from the development earlier, that's the way to go.
There's a few things that I haven't understood before and sort of understand a little bit better, and those sort of new techniques we often come across, sites where there is fuel or diesel pollution in the ground, and what's the best way to get rid of it. So it's good to know there's new ways coming forward and more sustainable ways, because that's the way the world is going, isn't it? Trying to be more green and better. So when you're not looking at ground contamination, what sort of things do you enjoy doing?
Well, I mean, part of the job, I guess, and part of the thing that draws you to doing geology and being happy to stand in a field for hours in the rain means that you have to be a type of outdoorsy person. So I like to go out walking, and I like going to the Lake District, North Wales, getting out there, getting up the mountain, and appreciating what we've got. So that's what I tend to do when we're not locked down and restricted to indoors.
I think there's a lot of people that probably can't wait to go and do that sort of thing again. We really enjoy going to Brecon Beacons, cycling and walking. But obviously, we haven't done that for quite a while now. So hopefully, I think there's probably hundreds and thousands of people looking probably to do the same thing in the summer this year.
Right, it'll be a procession up the hill, I guess. Everyone in a chain, in a line. Let's see. But it'd be good to get back out there again. So that's what I like to do. Also, I like watching motorsports, like Formula One. You can do that from inside your own house. You can go to a race if you're lucky enough when it's local. But for me, I say I'm probably an armchair fan of Formula One at the minute.
Yeah, well, I've got a few friends that are absolutely mad for Formula One, and they've been to loads of Grand Prix everywhere. I'm not a massive fan, but then I started watching a series on Netflix. Can't remember what it's called now, where they follow the season.
Race to
Survive, was it something like that?
Race to Survive. That's a really good thing to watch.
Yeah, so I did quite enjoy that. So who knows, maybe I'll start watching the actual racing a bit more.
Yeah, it's quite a commitment. The race is quite long, and I find that you have to be. The interest of it is looking at the technical side of it. Seeing the cars go around the track is on some of the circuits. It's just a procession, and you kind of know whoever's on pole. They may win. They probably will win. But for me, it's the technical background to it. Hearing what the teams have to say, looking at the newest developments they've got, aerodynamic packages and things. That's the side that gets me.
Yeah, well, I can understand that, because you're talking to someone that could literally sit for 3 weeks and watch a bike race, and read everything about it, all the tactics, the new technologies, and all the controversies around different people, that sort of thing. So I fully understand that. Yeah, so thank you very much for today, Tim. That was really interesting, and I think I've learned quite a few things along the way there. I made a few notes to sort of try and provide a summary at the end. I think one of the main, or a few of the main points for me are, if you're at university studying a degree, then getting some work experience in a relevant field is probably one of the most important things you can do, both for learning purposes and for your own CV. In terms of the ground contamination itself, it's getting in there early, having your initial phase one desktop done to sort of identify, are there any risks. And what I found quite interesting was, maybe just because you have a site that looks perfectly clear and clean, i.e. maybe a nice field somewhere, it doesn't mean that some contamination from a site further down the road seeped onto your site. So knowing it's there will be really important, not just for costs, but also for a headache later on in terms of having to clean it up.
Mm.
And I found the sort of changes in the way you're dealing with contamination quite interesting, in terms of trying to keep it on site because it's more sustainable rather than taking it away and giving it to someone else to deal with.
Oh, very good, very good. Yeah, hopefully it was interesting to the viewers as well. But yeah, I've enjoyed it. Thank you.
Yeah, cheers, Tim, and I'll see you soon.
Brilliant. Thanks, Tom. See ya.